In this video, you'll learn about SQLMap, a powerful open source tool for automating the process of detecting and exploiting SQL injection vulnerabilities. At first, we start from a very basic command with the -- crawl option. The depth of the crawl starts from 0 to 4. Just continue the video, we'll tell you what is the crawl option actually is. And here is the details of vulnerable parameter, types of the query, and the used payloads in each queries. And this is the vulnerable URL. This is method. This is parameter. B for Boolean-based blind queries. E for error-based. T for time-based. And U for union-based. Just follow the chart. We also use this initials with the technique option for specific queries. Like example, we are using -- technique equals U for the union-based queries. Please don't skip the video. If you skip the video, then at the end you may miss many things. And now you may understand the output, which is URL, method, parameter, and technique, right? If yes, then comment down below. Now, let's jump to the next part. And now, let's explore the -- thread option for speed. The limit of the value is from 1 to 10, where 1 is the default and 10 is the super fast. Now I am using the -- crawl option in depth 3 and the thread option with the value of 9. This is the vulnerable parameter. This is technique, and now you may understand the whole things. That is why I am not describing it repeatedly. Now you may wonder that what is the -- crawl option is. Just follow the chart. Crawl is an option that allows the tool to automatically follow and analyze links on a website, starting from a given URL up to a specified depth, like the chart below. Now let's get toward the -- level option. In SQLMap, the -- level option controls the depth of testing performed during SQL injection detection. It adjusts how many types of payloads and test cases SQLMap will attempt on the target. Just follow the chart. But remember, increasing level can increase noises in the network, where 1 is the default value and 5 is the maximum, and also very noisy and slow. In this video, we're using level 2. And now this level 2 is not going to check only injectable parameters, it also checks the HTTP GET and POST requests also. Now let's get toward the -- risk option. The -- risk option in SQLMap controls how risky or potentially intrusive the payloads used during testing are. It defines the aggressiveness of the SQL injection tests. Just follow the chart. In this video, we're using risk at level 2. That you know this section is for vulnerable parameter, queries, and used payloads. The -v option in SQLMap controls the verbosity level of the tool's output, that how much detail should it show during execution. Just follow the chart. In this video, we are using verbosity at level 4 to view all payloads and requests. Here is all of the requests. Here is the info of all requests and payloads that we've sent to the server. This first one is false positive or unexploitable, and the second one is exploitable. The --output -dr option in SQLMap specifies the directory where scan results and logs will be saved. Now let's explore the --fresh-queries option. The --fresh-queries option forces SQLMap to ignore previously cached results and retest the target from scratch, ensuring fresh and accurate detection. Now let's come to the part of evasion of SQLMap requests for performing the real-world scenarios. Evasion in SQLMap is essential in red teaming because real-world targets often have security controls in place that detect or block automated tools like SQLMap. Evasion techniques help testers simulate how a real adversary might sneak past defenses, making the assessment realistic and effective. Let's get started with the --header option in SQLMap. At first we see the normal method and its requests with the -v4 option. Here we can see in the user agent section that all the requests are going from our SQLMap. That's why in real case the firewall can easily block our requests. So in this case, we can change the default user agent with the --header option. The method is --header equals your custom header. Like in my case, I am using custom header for user agent. Now you can see that all of our request is going from our custom user agent. You can also use multiple headers at the same time, like I am using refer and user agent at the same time. I have merged the two headers with the help of the new line character, \n. Let's see the requests with the verbosity level 4. You see that we added a new line of a refer, and we also changed the user agent section with our custom user agent. It makes our requests look like they're coming from a real browser, not from a hacking tool. That helps to bypass a basic web application firewalls, filters, and bot protection mechanisms. You can also change the user agent with the help of --user-agent option. Now you may wonder that why I am using the --batch option till now with all of the previous commands, right? Here is the quick answer, that the --batch option may help you to run this tool automatically with the default yes. No, and also other type of arguments. Now let's jump to the next option, the dash mobile option. The dash mobile option makes SQLMap send HTTP requests with a mobile browser user agent, helping to evade firewalls or filters that apply stricter rules to desktop traffic. In this case, we haven't used the dash batch option because sometimes we need to choose our custom choice. Let's suppose we choose the Samsung Galaxy S8 device user agent where the default is Apple iPhone 8. Now you can see that the requests are going from our custom Samsung Galaxy S8's user agent. Now let's reveal the next option, which is dash random dash agent option. The dash random dash agent option uses a random real browser user agent string to help evade detection and appear as legitimate traffic. You may see that the default SQLMap user agent has been changed. Now let's jump to the next option, which is dash tamper. For that you need to know all the default tamper scripts. For that, just use the dash list dash tampers option. Here is all of the tampers that you can use to bypass firewall, filters, and input validation mechanisms. Because the tamper scripts in SQLMap applies custom scripts that modify payloads, which can help you to bypass some firewalls, filters, and input validation mechanisms. Let's suppose we were using tamper script of base64 encode to encode our payload into base64 encoding. And let's inspect our each requests with a level of verbose 4. Here we can see that our all payloads are not going into a raw format. All are base64 encoded. Now let's talk about the exploitation part of the SQL vulnerabilities through SQLMap tool. In our previous clip, you may see that we found 2 SQL vulnerable parameters. Now let's grab the information using them. At first, we grab the current user information of the database using -- current - user option. Here we found the current user of this database is AccuArt at localhost. Now let's fetch the host name from the server using the -- host name option. Here we found the host name. And now let's find the current database information with the help of -- current -db option. And here is the current database information. At previous clip, we found the current database name, which was AccuArt. So let's find the table entries of that database. So let's give the name of the current database over -D flag and find the tables with the help of -- tables option. Now we have found all the table entries of that database. And now the entries of the table seems to be interesting in the case of that particular user's entries. So let's dump that user's using -- dump option. Now we have found the username and password from that SQL database. Let's check it out. Now let's operate this command without that -- batch option to manually enter our custom word list file to crack the SQL database hashes. Let's create our custom word list file for demo. Let's find the data type of the columns using the -- columns option. Here we can find each column's data type information. And here the varchar means variable length string data type, which can stores up to n number of characters. In this case, that n is equals to 100. And the medium text is the large text field that can store up to 16,777,215 characters, means 16 megabytes of text. You can also find the database information with the help of --dbs option. We're just showing you that method just for your curiosity. Otherwise, we've already found the current database using another method. Let's dump the database through login page exploitation with the help of --form option. For that, we need to find the variable name, which is storing the values of username and password. We've got that variables through inspecting the section of the username and password. The variable for username is uname and the password is pass. Now we've found that vulnerable endpoint. Let's use the post data with random value and submit over the --data option. Now we found all databases information through just a login page. If you found this video helpful, be sure to check out my other videos on cybersecurity tools and techniques, and let me know your thoughts in the comments below.